Welcome to the second worksheet in the Week 10 Binomial Option Pricing workbook. And in this worksheet, instead of looking at a one time step ahead, two-state binomial tree, we're going to include 2 time steps. So in the first problem, what I ask you to do is to extrapolate the stock prices going forward, not just one time step as we did in the previous worksheet, but two time steps. And this is a simple process. All you need to do is to remember that the next time step from here to here, and the next up step of the evolution of stock prices is simply the value of the stock price in the previous time step, and because we're moving up, it's multiplied by the up state, which is 10%. And you can see that we simply, in Excel, we do that arithmetic. This is a little bit more complex, this next time step, because we're now going up one time step and then down in the next time step. So it's an up and a down. Once again, very easy to implement in a spreadsheet. We take the previous time step, and instead of going up by 10%, we are now going down by 3%. And likewise, for the third and final yellow box, the final leaf in the tree, we're going down by from this previous time step of $48.50. And so here we have, in total, the time evolution of the stock price, the underlying price, over not just one time step, but over 2 time steps. The final leaves here of this tree represent the values of the stock at expiry. Okay, let's now go to problem 2. In problem 2, what I ask you to do is to take the information from problem 1 and apply it to price the call option with a strike price of $50. How do you do that? Well, the first step is to calculate the value of the option in the leaves of the tree here. How do we do that? Well, we simply apply the knowledge that these leaves coincide with the expiry of the option. So this time is the expiry time of the option. And we know the expiry of the value of the option at expiry by applying the max 0 S minus K formula. And this is essentially it. For the top leaf, we take the value of the stock price in that top leaf, $60.50, and we subtract the exercise price, $50, or 0. Now, if we take $60.50 and subtract 50, we get $10.50, and that's clearly worth more than 0. So, in this state of the economy, the value of the call price is equal to $10.50. In this state of the economy, the stock price is equal to $53.35, and the exercise price is $50. So, we take $53.35 minus 50, or 0, whichever is larger, and it happens to be $3.35. And in the final, or the lowest leaf, we can see that here the stock price is $47.05, which is less than the exercise price, so clearly the call option here is worth 0. So we find the value of the option in the leaves of the tree. That's easy. How do we find the value of the option in the nodes of the tree going backwards from the leaves? Well, here we apply the state prices that we calculated in the previous worksheet. What we simply do is we know that to find the value of the option today, it should be a combination of the upstate state price, 0.6531, multiplied by the value of the option in the upstate, and the downstate state price, 0.2903, multiplied by the value of the option in the downstate. That combination will give us the value of the option today. And it's equal to not today, but in the previous time step, and it's equal to 783. And we do the same thing for the previous time step, for the lower node. Finally, we get to the root of the tree, and we recursively reapply the state pricing to get the value of the option in the root of the tree, which coincides to the value of the option today. Of course, that's the value that we're actually interested in. So, we once again use the state prices, we multiply by the value of the option in the upstate and the downstate, and we get the value of the option today, $5.75. So, I hope you can appreciate that the binomial option pricing tree really is quite simple. You time evolve forward, from the root of the tree going forward to get the value of the stop price at the leaves of the tree. Then, knowing the values of the options unambiguously at the leaves of the tree, you calculate those values and then work backwards in the tree to get back to the root using state pricing to find the value of the option today. It's as simple as that.